Hello, Weekly Coders, and welcome back to another episode of the Weekly Coder. We are going to continue on from where we left off. I believe we were on part 7. We are now on part 8. Part 7 basically left us with a fully functional 2048 clone. So what we want to do now is we want to build upon that. We want to make our clone look as good as the original. Maybe a little better at some point, but right now we're striving for that authentic 2048 look. And what I mean by that is that we can't just have our tiles just kind of transform from over here to over here. So like 2, 2, and a 2 is just like you press left and the 2 just goes like, alright, now I'm over here and I made a 4 just out of nowhere. There's no sliding animation, there's no like pop animation, there's no sound, there's no nothing. It just bam, it just happens. It's like you teleported it and it merged and became something else, which is what would probably happen if we ever did teleport something unsuccessfully, is we would merge and become something else. So with that said, stupid awkward moment out of the way, what we need to do in order to make this happen is you have to realize that the way that things are going right now is that our program executes everything in one frame. So all the moves that happen in one frame. So let me put that into perspective for you. Our game runs at just about 60 frames per second, okay, on a good computer. On a slower computer, it might run slower, but on a normal computer, our game's going to run at 60 frames per second. And that means that one frame of programming in the update loop, so like everything that you write in your update loop, so when you create a method and you call that method from the update loop, that's going to run once per frame. If you put a for loop in there, okay, so if you've got your update method and you have a for loop that iterates over 1,000 iterations doing some kind of weird math or some if statement, that means that is going to run that many times per that one frame. That one frame, okay? So when we're talking about frames as far as like visually, what we're seeing, our code is running 60 times. So every for loop that has 1,000 iterations is running 60 times in 1 second. Okay? So that includes the screen refreshing, the redrawing, and all of the updates and everything else that's running in the background is running 60 times every second. The way that our code works right now is when we press left, up, right, or down to move our pieces, we're moving our pieces, but we're moving them in one frame. Okay? So can you try to imagine what you could literally see happening visually in one frame? Nothing. Because that's 1/60th of a second. Your eyes can't even see that fast, so you can't pick it up. So our pieces are moving faster than what we can see. So literally what we need to do is we need to slow them down. Maybe we need to move them one like tile every 15 frames or so that it might take a second for one tile to move all the way from the right to the left. That might be kind of slow. So it might be, less than maybe 7 frames. Either way, we're not going to concern ourselves with how many frames we're going to try to make this happen in. What we really need to figure out is how are we going to actually do this? How are we going to make it so that it seems like we're going to have to modify like the core workings of our game, right? And to some extent you are right. We're going to have to make a lot of modifications. So what I actually recommend is if you want to follow along with this, I would recommend that you make a copy of whatever project you have up to this point, so that you can, you don't need to worry about accidentally screwing something up, and then you can just go back to your old project, okay? Don't work on a project that's working, because it would suck to have to go back through videos 1 through 7 to get back to a working game just so that you can retry the things that we're going to do in tutorial 8. This is going to be a pretty big one, and we're probably not going to tackle all of it in one go. There might be a part 1, part 2, because it's going to be pretty long. So what I'm going to do here is we're going to use a method that's available to us on the vector2 struct that is going to allow us to basically move something or change something over time. Let's call it that, and that's basically called a lerping function. Okay, so lerping is doing something over a period of time. In this sense, what we're gonna do is we're going to use the lerping method along with the IEnumerator so that we can create basically a method that's a parallel processing method outside of our main game loop. So what happens is our calculations happen, right? Our tiles are going to figure out where they need to go. So let's say there's a tile 2 over here and a tile 2 over here. We press left, and what happens, what we'll do is we'll create a like a phantom direction or a phantom position that we're going to keep track of. Okay, so what's going to happen is this phantom position is going to start out with where our tile is, and then it's going to be equal to this, and then it's going to be equal to that, and it's going to be equal to this, and it's going to say, hey, can I merge? If not, send me back, and then this is what I'm going to be equal to. So let's pretend for now that this is where it's going to be. So this tile then needs to store what its starting position is and its ending position, okay? Or its move to position. So we're going to create 2 new variables in our tile class that we're going to use to store information. In the same way, we're also going to need to know that if this also had been a 2, this tile would merge with this tile, so we would need to know if this tile were going to merge with this one, so we would need a way to store this tile as a property of this tile. So we would also create another variable for that to store that information. So once we've figured out, we've pressed left, and in our one frame of calculations, we've figured out where all of the tiles are going to move if we press left. So now that we know where they're all going to move, in the very next step in our programming, we can say, okay, let's iterate over all of the tiles and check all of their properties to see where they are and where they need to go and what needs to happen, whether they need to merge or not, and then call a lerping function for each one of the tiles to make those moves happen over a period of time. During this period of time, we are going to need to make we're going to need to figure out a way to keep the player from pressing buttons, because we don't want our tiles to slide halfway and then the player decides, oh, I'm going to press right now, right in the middle of the move, and then all of the tiles are going to get confused because their positions aren't going to be set and they're going to just slide all out of place. So we need to disallow the player from making any kind of movements while this is going on. That's important. So I think that's pretty much all of the pseudo kind of code, thought pattern, logic kind of way of thinking out of the way. And I think now that we have some like practical idea of what we need to do, we can get started. I would like to point out that this was probably one of those things in this project that I was really excited about, because it was a challenge even for me at that point, because it took me a second to get my head wrapped around the fact that when we're moving tiles, we're not actually moving tiles. We're kind of testing the tiles being moved, and then they're being redrawn on the screen. So you have to kind of think of everything in a sequential kind of programmatic way, in such a way that it happens repeatedly over and over and over again over time, and that's when things happen. So the code that I'm going to share with you, I'm going to rely really heavily on my reference code that I started with. So you're going to see a lot of, this. And I'll be looking back and forth. I've already tried, and this is where it gets me, is I've already tried to create a video to kind of share this with you guys. And I failed miserably. I sat there and I recorded a video for like an hour and 45 minutes. And at that point, I was like, oh my god, you know what? I'm just going to give up. And we're just going to like start over. And I'm going to just give it a day or two and figure out what I did wrong. And oddly enough, I came in here and I was like, let me look at this and see. Oh no, here's the problem. That's where I found it. So it sometimes takes to like step away from a problem to come back to it like a day or two later, get a fresh look on it, and then you look at it and you're like, oh my god, that doesn't make any sense. Why did I do this? And that happens all the time. You wouldn't even realize how often I come back to a project, even like a year later, and I'm like, wow, why did I do this? This makes no sense. So I'm sure if I come back to this a year from now, I'm going to be like, wow, that was dumb. I could have done this in such a more efficient way. And that's the thing about programming is there's always a better way to do it. And I mean, I guess at some point there might not be, because you can only be so efficient. But then some other guy does something else and you're like, well, I didn't think of that. That could have helped me. Anyways, enough rambling on. What we're going to get started with is not the sliding. We're actually going to get started with the popping in of the tiles. So you know how when you're playing 2048, the tiles don't just like materialize. They don't just like, there we are. They kind of like pulsate out to you. Like they shrink right there. They start like in a small way. They start in a small way. They start small and then they just kind of, go up in size until they are at their one scale. And that's what we're going to do first before we get before we do any sliding. So, and before we do that, the very first thing that I would like to do is I would like to actually create some variables, some properties in the tile class, because like I said, we're going to be adding to that. So we're going to do first is we are going to open up our scripts folder and then go into the tile class. So right now it's very, very simple. It's just the tile value and the merged this turn. So what we're going to add is we're going to add a vector 2, and that's going to store our starting position of our tile. And we're going to add another vector 2, and that's going to store our move to position. And then we are going to add a boolean, and we're going to call that one destroy me, and we're going to set that to false. And then we are going to add a transform type, and that one is going to be called colliding tile. And finally we are going to add another boolean value, and that's going to be called will merge with colliding tile. Okay, so I'm not going to get into what these do just yet, but we are going to talk about them as we use them in the game class. So let's switch over to the game class. And we're going to be adding a few variables here as well. So let's scroll all the way to the top and add some variables. We are going to be using coroutines, and the best way I've found to keep track of how many coroutines are running is to just simply create a variable that we are going to increment and decrement by the number of coroutines that are running. And you'll find out why that's important in just a little bit. Coroutines running equals 0. Then we are going to create a boolean, and that's going to be called generated new tile this turn equals true. And then we are going to create another boolean, and we're going to call this one user input enabled, and we're going to set that one to true. Ooh, that's bad spelling. And that is it for now. See you guys next week. Kidding. That would have been the easiest tutorial ever, right? Variables. So I think the first thing we can do is we can utilize this number of coroutines running and change our update loop to incorporate that. So basically what we're going to do is we're going to say if number of coroutines running. Oh, no. All right, we have to respell that. Running. There we go. So running is 0. Okay. And that means that no coroutines are running. And then we're going to say if not generated new tile this turn, we're going to set generated new tile this turn equal to true. And then we're going to generate new tile 1. And after that if statement, we're going to set user input enabled to true. And let's see what else. If game over, user input, active to true, else, and then we'll have this all right here needs to be in here, and then here we're going to create an else condition, and that is going to be user input enabled equals false. All right, so let me just kind of go over this. Okay, what we have is in our update method, we are going to check to see how many coroutines we have running. And remember how in the beginning I talked about we want to limit the user's interaction with the game. So we don't want the player to be able to press left, right, up, or down when there's a move happening, like when we are actually sliding. When we have our coroutines that are parallel processing to our game loop, when we have those going, we don't want the player to have any kind of input. So we have to keep track of how many coroutines are running. And if there aren't any running, then we are inside of this if condition. That means we can say, hey, user input is enabled. Okay. Otherwise, if this does not equal 0, that means that we have coroutines that are running. That means that we don't want the player to have any input, which means we set user input enabled to false. Okay? So then all we have to do here is say if user input enabled, then we check user input. Okay? If user input's not enabled, then we don't check user input. Interesting. We're going to circle back to this because I'm thinking that if number of coroutines running equals 0, that means that user input is enabled, which means that all we really need to do is check to see if the number of coroutines running equals 0. Because, yeah. Okay, so we don't really need this. And we don't need that. So we don't need this. And we don't need this. So basically, yeah, we didn't need that Boolean because if we know that there aren't any coroutines running, then we can allow this check user input to run. If this is 1, then we're never even going to be in this if statement, and none of this is going to actually run. Which I'm fine with. We're going to get into in a minute, because this is actually part of something new that we've got to do, and that's going to be coming up very, very soon. The next thing we're going to talk about, I think, is the generating of tiles. Because right now, like I said, they're like just teleported onto the screen from being nothing to just being there. We're going to make them pop in. And for that, we are going to create an IEnumerator method. So we're going to go all the way to the bottom. So that's where I like to stick my enumerator methods. So IEnumerator. And we're going to call this one new tile pop in. And we're going to need a parameter for the game object, of course the tile. We're going to present a vector 2 of initial scale, a vector 2 of final scale, a float for time scale, and then a vector 2 for initial position, and a vector 2 for final position. Okay? So, what are we going to do with all these? Well, the first thing we're going to do is we're going to say number of coroutines running minus minus. Or plus plus, sorry. So we're adding a coroutine, since we're calling this. And at the end of the coroutine, we're going to say number of coroutines running minus minus. So then everything we do in between these two is the actual coroutine. So we're going to do float progress. And that's just going to help keep track of our progress in our while loop. So we're going to say equals 0. Then we're going to create a while loop, and we're going to say progress is less than 1, or also equal to. So while progress is less than or equal to 1, we're going to do tile.transform.local scale equals vector 2 dot lerp. There's that lerp function. Initial scale, final scale, and progress. And then we're also going to do the position. Tile.transform.local position equals vector 2 dot lerp initial position, final position, and progress. Because remember, we set our anchor point for our tiles to be our pivot point, if you want to call it that. We set that to be the bottom left. So our tile scale is going to be scaled from the bottom left. So if we scale from the bottom left, then our tile is going to scale weirdly. It's going to scale from, like, let's say that this is the corner. Our tile is going to scale big like this instead of big from the center. So we have to actually move it to the center and then let it scale on all sides to make it look nice. So at this point, we're going to increment progress. So by time.delta time times the time scale. So how long we want this to take. And then, very, very important, we have to return null so that it doesn't lock up. And then we need to do one more step, and I'm going to explain this in a second. Let me get this written down. Local scale is final scale, and tile.transform.local position equals final position. And the reason that we do this is because it's very possible for this progress, because it's a floating point number, or a floating point I want to say floating point integer, but that's really bad. It's a floating point decimal. It's a decimal number. It's a floating point. It's a floating point decimal. Decimal integer number. Okay. Floating point arithmetic. Here we go. So, because we're dealing with floats, we have to account for the fact that when progress is less than or equal to 1, that progress could stop at 0.98 or 0.99 or even 1.02 or 1.5, depending on the frames per second that we're running at and the delta time that we've got between our actual frame time. And, there's lots of calculations to consider. Just know that we're probably never going to end at a perfect 1. So what we do here is after we think we're at 1, right? After we think we are where we need to be, we go in and make sure in that final frame, we say, hey, just in case we're not at our final scale and at our final position, we're going to ensure that we are at our final scale and our final position. And that's what that does. So now, let's look and see what we've got to do to implement this method when we generate new tiles. So in the generate new tile method, so let's find that. Generate new tile. What? Generate new tile. Okay. Nope. There we go. Alright, so here's our generate new tile method. And what we want to do is we want to set our scale. Let's see here. The last thing we're doing here is new tile transform. Yep. Alright, so after we do this, we want to go to our grid. We're going to set. Alright, I'm going to get into this in a second here. Let's type this up really quick. Transform new tile transform dot local position dot x int new tile dot transform dot local position dot y equals new tile dot transform. All right, so what we're doing here is we're basically just adding the new tile to the grid, and we're not going to call update grid anymore. Okay, not from generate new tile anyways. So no more updating the grid from generate tile. We're just going to add it to the grid directly. So then we're going to do new tile dot transform dot local scale. Guys, is it just me, or like does Visual Studio have like the crappiest like autocomplete ever? I really miss mono develop. This is insane. Like I can't deal with it. I type, sometimes I do quotes, and I appreciate that it has the extra quote, but sometimes it puts a quote where it doesn't need to be one, and like the angle bracket, and don't get me started on like the curly braces starting below the whatever. Like if it's a for loop, an if statement, wherever you could put a curly brace, it automatically wants to put it below. It does not want it to be beside. All right? That's I can't deal. All right, whatever. New tile.transform.local scale equals new vector2 0 0. All right, so what are we doing here? We're taking the scale of our tile and we're setting it to x equals 0, y equals 0. What that does is it shrinks our tile down to nothing. Okay, like it doesn't exist. Invisible. New tile dot transform dot local position equals new vector 2. This is going to be crazy. New tile dot transform dot local position dot x plus 0.5 f. New tile dot transform dot local position dot y plus 0.5 f. All right, so that is what I was trying to tell you guys, is that we need to shift our tiles over. So it's going to go over 0.5 in the x, and it's going to go up 0.5 in the y, and that's going to put our tile in the center. Okay, but not really. It's gonna make it expand outwards, because what's gonna happen is because we're also in our LARPing function, we're also moving towards a position. Okay, so what we're doing is the tile starts like, all right, so this is the square, right? This is the square, and then our tile starts as a dot in the center. And let's say that we let this tile like expand to full size. What would happen is it would grow in here and it would sit here. But as we're growing it, we're also moving it to here. So it's moving and growing at the same time. So it looks like it's coming in from the center. So it's like a trick. It's an illusion. So now we're ready to actually show our tile. So we're going to do start coroutine. New tile, pop in. New tile is what we're passing. And then we're saying new vector 2, 0, 0. That's our initial scale. Our final scale is going to, of course, be 1, 1. New vector 2, 1, 1. And then our time scale is going to be 10f. And then we're going to give it a initial position, which is going to be new tile dot transform dot local position, and then new vector 2. Oops. Vector 2. New tile dot transform dot local position dot x minus 0.5 f. So it's going back to where it needs to be. And then finally, the final position, new tile dot transform dot local position dot y minus 0.5 f. And then we close that and one more, and we're done, I think. Unless we missed something. We missed something. New tile, new vector 2, new vector 2, 10f, new tile, dot transform dot local position, yep, new vector 2, new tile, oops. So this is a vector 2. There we go. That's better. All right. So let's try it. See what happens. Whoa! How cool is that? See how they're popping in? Huh? That looks pretty good, right? I mean, that almost adds like a whole different like gameplay to the game. It just makes it look so much better. I mean, if you guys aren't seeing this, I can slow that down for you a little bit. So instead of going at a 10, let's make it go at a 1. You'll see it's really slow. See that? So this is indeed happening, and The good thing is that our method that is keeping us from pressing keys is working exactly as we designed it, because it is not letting us actually give any input until the loading of the tile is completed. So we're obviously not going to keep it like this, because that would make the game extremely boring to play, because oh my god, it would take you like an eternity to get to 2048. So I think what I'm going to do is I'm going to stop it here, because the video is probably already too long. Because I talked a lot in the beginning, which is great, because now I don't have to do that in the next video. The next video, I'm just going to be like, okay guys, let's pick up from where we left off and finish this thing. Because the next part is going to get seriously insane. It's going to get really crazy, because there's so much modification to the code we're going to have to do. I just don't want to throw it into this. I want to give you guys some time to kind of absorb the material that we've just covered, because it was a lot. You know, I mean, we did so much. We actually did a lot. We added animation to our game without really animating anything. You know, it looks cool, right? We did something with programming. We programmed, and not really, because that LORP method pretty much does all the hard work. But we did a good job. So pat yourself on the back, and you know, come back for the next tutorial next week, and we'll finish it up, and the game will look awesome. And then the tutorial after that will be about sound. And then after that, we're gonna have some cool things, because those will be just extra little things that you can do to make your game fun. And after that, well, that would probably be the end of it. Then we have to start a new one. So if you guys want to start your requests now for new tutorials, feel free to drop those down in the comments. I am happy to entertain all thoughts. If you like the video, give it a thumbs up. If you like the channel, subscribe, click the bell for updates. And as always, you guys are the best. I appreciate each and every one of you. All my weekly coders out there. With that said, someone asked about a Patreon channel, and I do have one. A Patreon channel. A Patreon site? Profile. Yes, I have a Patreon profile, so you can go donate there if you like. And feel free to do that, because, I mean, money is always welcome. I do this for fun, but, you know, boy, would I love to just sit home and just make these tutorials all day for you guys. It would be never-ending knowledge for everybody. If I could do this all day, I do this for about an hour to 2 hours, you know, after work sometimes only on the weekends. So if I could make this a job, then it would be amazing, because I could get so much material out to you guys. It would be incredible. And if you want to help support that and help me build that, hey, I am more than happy to take any and all donations from all of you guys. Again, thanks for watching. I'll see you guys next week.